Alright, this video finishes up chapter 8, and it's all about mining. Once again, there are terms that you've never been exposed to before, but you must know every one of these words that I'm going to teach to you are terms that have been used on the AP exam and on the ACE exam. So you're going to have to memorize them. I think that's the only way really to do it. Maybe you've heard the terms before, but I kind of doubt it. We're going to go through the different mining techniques that are used today, and of course there are big environmental implications with all of the mining that we do. So here's the end of chapter 8, mining. Okay, let's begin. You can follow along beginning on page 226. And the most important thing I wanted to point out to you from this diagram is the fact that the Earth's crust, the number one element in the Earth's crust is oxygen. That has been a direct multiple choice question on the AP exam before. And that's counterintuitive because you think of all of these other things as important elemental parts of the Earth's crust. Of course, we do a lot of mining for aluminum, for iron, all of these different elements, silicon also. But the number one element in the Earth's crust is oxygen. Why do we bring this up? Well, it's because these are the principal elements that we mine for. There's a reason why mining is such an issue. It's because these elements are in the Earth's crust and we have to dig them out. And it goes through a great big processing technique. It's not just digging the ore out of the ground, but it's all the processing that has to be done in order to get these elements out of the Earth's crust. And lastly, there is a discrepancy between where all of these elements lie in the Earth's crust. There are some places in the world that are rich in these elements, and there are other parts where there is not much of these elements. So it becomes an issue of mining them, getting them out of the ground, processing them, and then getting them to countries that can use it as raw materials for the making of goods. Here are the approximate supplies of metal reserves, global and US. Here's the global, and then here's the US, and you can see we have lots of years of these different metals. But notice that there are some places, there are some of these metals that we don't even have here in the United States. We have to import them from other countries. These metals are important in all sorts of manufacturing, as you can imagine. And of course, some of these metals, like gold, are highly valued just because of they're highly valued in society, so therefore they're worth a lot of money. You can see why we use a lot of aluminum because there's plenty of it available, and you can also see why here in the United States we are big on recycling aluminum, because we don't have a lot of aluminum in our country, in our part of the Earth's crust. But we will mine for something called bauxite, and this is another one of those words that's been on the AP exam before. This is the ore that we mine principally to get aluminum. The actual aluminum itself is very, very rare elementally, but it's usually found in compounds like bauxite. So we mine the bauxite and then process the bauxite to get the aluminum out. The term reserves just means how much is left in the Earth's crust, and you'll hear that term a lot. I'm sure you can understand what that word means. Reserves are what's left over, what we have left, and that's what we're talking about here in this diagram. Let's talk about the types of mining. I have videos to show you a lot of these different kinds, but basically it boils down to two principal types. Subsurface, which is underground. You know, that's where we dig down into the earth using tunnels and shafts. We support those tunnels and shafts as we go to help protect the miners. Subsurface mining is very, very dangerous because you're going underground. And then surface mining is getting the ore from the outside, digging down. Rather than going underground to find our mining, we cut away at the surface. And there's several different types of mining. The first is called strip mining. And here are some terms that you need to know. First of all, it's mining spoils. Sometimes you'll hear it called tailings. Both of these words mean pretty much the same thing. Mining spoils are unwanted rock that has to be removed before you can start digging for the mineral that you're trying to find. Tailings are the rocks and waste that are left during the processing of the mineral. So tailings usually exist at some factory later on. Gangue is something that produces tailings. Gangue is the waste that's in the ore. You can imagine when you're digging for, I don't know, pick something. You could even say something like gold. But when you're digging for any sort of metal, there's going to be dirt mixed in. There's going to be other compositions. It's going to be other compositions that get in the way of you finding that one ore that you're looking for. This mixture of unwanted really materials is called gangue. And then overburden. Overburden is what's on top of the ground that you have to dig through in order to get to the ore. It's the dirt on top, basically, hence the word overburden. Strip mining is mining that where we dig into the side of the earth in strips. You've probably seen lots of examples of that. Certainly I've got a diagram to show you where you can see it. Open pit mining is a little bit different than strip mining because strip mining usually goes into the side of the hill, where an open pit mining is where you dig a hole down into the earth. Mountaintop removal is just like it sounds. This is where we go to a mountain, we start at the top of the mountain, and we start to dig right into the top of the mountain. And there are examples, for instance, in West Virginia where there's actually no mountaintops anymore. Where they've dug in to get coal, they've dug into the top of that mountain and used up every bit of it. And then the last kind of mining is called placer mining. Picture panning for gold, because placer mining comes from trying to find the metals and the ores that you're looking for in a riverbed.
Strip mining is a surface method used to mine coal. An earth mover strips away the soil and rock overburden in order to get to the underlying coal. The power shovel removes the coal and the trench is filled with the overburden. A new cut is then made parallel to the old one, and the process is repeated until the workable coal seam is removed.
All right, there are your strips. Strip mining. Here's that diagram I was telling you about. This diagram is on page 227 in your book, and it shows all of these different kinds. Here's the subsurface mining that I was talking about, where we actually dig tunnels and shafts and really dig rooms almost, where our miners can go into go down the shaft through an elevator and then go down into these rooms, and then they can dig for the ore in those rooms. Subsurface mining, again, is the more dangerous of the two. Less environmental hassle, because you can see it's not doing a lot of damage to the mountaintop. It's digging down in and building these corridors and shafts, but very dangerous for the people. Strip mining is digging into the side of a hill in strips like you just saw in that last video. Here's the mountaintop removal I was telling you about. Again, a nice picture of that, actually just digging starting at the top. Notice all of the habitat destruction that happens as a result of all this mining. Trees have to be cut down, and the ecosystem is really, really damaged. There's not a whole lot of furry little creatures that are going to be living in an area that's being mined. And that last example here is the open pit mining, where we take an area and just dig down from the outside down into an open pit. This table's in your book also. It shows you all of the different problems that are associated with the two major types of mining, surface and subsurface. Minimal dust at the site for subsurface, but there are emissions from fossil fuels because of all the equipment that has to be used to dig. Lots of dust and earth moving equipment here with surface mining. And of course, all of that overburden has to go somewhere. It has to be dealt with. We'll talk about how they deal with it a little bit later. Contamination of water. And the big problem with subsurface mining, this is surface water here, the big problem with subsurface mining is something called acid mine drainage. When you're digging down into the earth in subsurface mining, a lot of acid materials are used to eat away at the rock and the walls when they're in those corridors. Well, all of that excess mine drainage has to go somewhere, and unfortunately it ends up seeping through the soil and percolates through the tailings, ending up sometimes in the groundwater. And you can see the list goes on and on. Even though with subsurface mining there might be less habitat destruction, there is still the issue of big heavy loading trucks coming to and from the site. So that causes habitat fragmentation. We talked about the problems with fragmentation before. And of course, when it's surface mining, all the trees are gone. There is major destruction and alteration to that habitat. And the effect on humans. Air quality is a problem. Occupational hazards with subsurface mining because of the things that miners have to breathe in while they're down there. There's no real clean air when you're down underground like that. So here are the issues about mining. Let's go make sure that you have a nice list in your notes of these different environmental issues. First, obviously, is the construction of roads. In order to get to the mining site, roads have to be built in what used to be a pristine ecological environment. So that causes the habitat fragmentation I mentioned before. And of course, all of these trucks doing all of this work, burning fossil fuels means more carbon dioxide into the air. Damage to waterways. Talked about how everything seems to use gravity to get to its lowest point, and that's how water ends up in rivers and lakes. Well, if we're doing damage to the ecosystem with our heavy machinery and actually even digging down into the earth in the case of surface mining, we're doing damage to the local waterways in that area. Habitat fragmentation, we already mentioned. Tailings, this is what's left over after we separate the ore, and that has to be dealt with. It has to go somewhere. It contaminates surface waters and groundwaters. Sedimentation is the buildup of the overburden in rivers and lakes that harms the aquatic habitat. Acid mine drainage, I've already mentioned to you. A lot of acidic materials are used to eat away at rock, and that acidic liquid has to go somewhere. It ends up seeping into groundwater. Respiratory exposures are a big problem for subsurface miners. You're all familiar with the decades and decades of workers in the coal mining industries and the respiratory exposures like black lung disease. Asbestos is something that is mined for, so you end up with asbestosis, which is really lung cancer. And subsidence. Subsidence this is a term you haven't heard yet that you need to make sure you write down and understand. Subsidence is the movement of the earth, the shaking of the earth that occurs when we do subsurface mining. You can imagine all of these big holes or pockets in the earth being bored away in order for us to do our mining makes the surface a little bit weaker. So we have a motion or a shift of the surface, usually downward. Can shake houses. You know, subsidence is oftentimes mentioned 20 miles away from the mine in the small town where all the miners live. And they can actually feel movement of the surface. This is called subsidence. Last thing to cover, and probably, well, the second to the last thing to cover is what we're doing to try to protect ecosystems from mining activities. The first law that you need to be aware of, and this is always tested on the AP exam, is the Mining Law of 1872. This law was very anti-environmental. Well, you can tell from the year 1872. They weren't thinking very much about what damage mining could do to the environment. And basically the Mining Law of 1872 allowed mining on any public land that existed. So mining companies could come in, they wouldn't have to buy the land, it wouldn't be their land, it would be our land, yours and mine, public lands, and gave them unfettered access to being able to mine for whatever was needed. Well, we started to figure out that that wasn't such a good idea. 100 years later, we had this law, the Surface Mining Control and Reclamation Act. And that word reclamation, very, very important for you. Reclamation means returning the area back to its original state. So starting in 1977, we passed laws that required mining operations, when they're finished in that area, to replace the overburden, plant trees, and reclaim, make that land good again, make it a habitable ecosystem so that eventually plants would grow and then the animals could come back. 1977. These other three laws, sorry about that, these other three laws have mining implications, but they're more important in other aspects of environmental science that we will cover. The Clean Air Act and the Clean Water Act speak for themselves. And then the Superfund Act was a law that was passed as a result of toxic waste dumping. And the idea with the Superfund Act was government would set aside an amount of money so that when a contaminated area was discovered, it could be cleaned up quickly. And we learned this from the Love Canal example in New York in the early 70s. We'll learn more about the Superfund Act when we talk about dealing with waste products, toxic waste products. Here are some pictures of reclamation, and you can see what ends up. Here's the mining initiative before. Don't know why it keeps doing that. Here's the mining initiative before, obviously a strip mining operation. But then what they left after the fact, they left a nice pristine area. Used to be mining companies would get everything that they could out of that land, as you can see here, dig and dig and dig until there was no more ore to be found, and they'd just leave the area, and it would look like this. Okay, so that's it for Chapter 8. It's a long chapter. There's a lot of things in it that I was not going to give short shrift to just because it's not my favorite stuff. A lot of new terms and things that you need to remember for your exam, which is coming up in a couple weeks. All right, see you later.